Hello, I'm Mark Tucker.
Hey, I'm Alan Furstenberg, and we are Two Voice Devs.
Two Voice Devs. Welcome, Alan.
Welcome, Mark. How's it going?
It's going well. It's moving along.
Good.
Learning new things.
We're back to moving along. Now we got that tune in my head again.
How about you? How things going?
Currently it is hot here, which I know it's the same there. It's also humid here, which is not the same as down there.
That's true. We've got extra hot, low humid.
I've been watching you posting stuff about building agents, and I've been playing around with building agents, and the rest of the developer community has been playing around with building agents. So maybe we should talk about building agents for an episode or two. What do you think?
That sounds good. There's plenty to talk about.
There's so much to talk about.
So there's, I think, maybe some terminology to get started out. What is an agent, or what is agentic AI, and does that have anything to do with agent mode from ChatGPT? Or so let's kind of talk a little bit about that. Make sure that we're understanding what we're talking about when we're talking about agents. And then we can drill down into, today I think we'll talk about two different frameworks / SDKs for building agents.
And those two
agent
frameworks
systems.
are?
It's the OpenAI Agent SDK for TypeScript.
Okay, and that's relatively new, right? They only released that
Yeah,
within the past few weeks.
Yeah, it is pretty new. And then and there's also a flavor with that you can do Python. And then another one I've been playing around with was Microsoft's Semantic Kernel. And you can use C#, which is what we'll talk about today. But I think it also does Python as well. So
no surprise that it does Python. I mean, I've been playing around with LangGraph, which has a Python flavor and a JavaScript flavor. There's also Google's Agent Developer Kit, which I've played around a little bit with, and that's in Python, and they recently released a Java version. So we can see where all of the parallels are going here.
Yeah, and it's not like Microsoft only has one agent type framework, and there's plenty of, like, everybody, I think different teams are doing different things, and everybody's trying to figure out what a good, better, or best approach is for doing this.
No, that's fair. Everyone certainly is. Although, well, I feel like there's lots in common and lots of overlap, but let's talk about it and see what we actually see.
Okay. So quickly on terminology, an agent is software, a model that can be used to do things, more actions, more tools. I guess you start thinking about, like, what are all the different things that an agent does other than just a typical call to an LLM. An agent pulls in a number of things. I like to look at it from the perspective of context engineering, and that kind of seems to solidify how I look at agents. So, like, if you think about it, when ChatGPT and its equivalent model came out, then you could ask the model anything that it was trained on, and it could answer you. And then if you wanted to have it answer different questions, you could fine-tune that model and then ask that fine-tuned model with the additional different questions. But then soon after, we came out with RAG, right? That's so that was, how do you get additional knowledge into the system that wasn't already part of the training of the original foundational model. So that's a component. I remember when things first came out, there was just one prompt that you would give, and it was the prompt that was used for everything. Mm-hmm. And then soon after, they divided that into the system prompt and into the user prompt. All of those things have been building towards more agentic AI systems, and those are all part of context engineering. So you have your system prompt, you have your user prompt, you have the additional knowledge that you can grab with RAG. You've got the ability to use short-term memory. That could be some kind of state that's in the system, or the history itself of what's been talked about. But you might also have more long-term memory, things that go across a specific chat session, or personalization stuff specifically about the user or about the context that you're working in. Mm-hmm. So that's more long-term memory type situations. I'm trying to think if I've missed anything other than tools.
I was going to say that's the one thing I would have added to that list.
Yeah, I'm thinking about actually. I had a post on LinkedIn where it was a Batman cartoon, and each of the different parts on his belt were some different part of context engineering, and his grappling gun was actually the tool. So I was trying to think if there's and structured output. So all those things are part of context engineering, and I think a lot of those things, as LLMs and Gen AI have grown over the last number of years, is things that now all come together to make a more agentic system.
I would add one other thing to that, and I don't disagree with any of what you said.
Yeah.
But I think the one thing I would add to that is the agent controller itself. I think there were a lot of people that were originally thinking all of this gets crammed into the LLM. And I kind of feel like what we've realized over the past couple of years is no, it doesn't belong in the LLM. Well, all of these things kind of hover around it. And the LLM may be at its core, but there's one thing that's coordinating the interaction of all of these parts. And that's the agent itself. I feel like that's the big difference, is that you could have had something before that, used RAG and an LLM, or used state and an LLM, used the context and an LLM. But it's this thing that brings it all together that makes it an agent, and that's the agent.
Yeah, and also just LLMs also growing up to be able to do more reasoning and planning. Because basically you put all these things together, you give a system prompt saying this is the thing that you're working on, and we'll get to a very specific example and talk about how that gets implemented. But all these things have to work together to figure out this is what the user wanted to do. What's the first thing should I do? Which tools do I need? Or what out of the tools that I have available, what tool do I call first? What inputs do I need for that tool? Now I have some additional outputs, and maybe another tool requires a different input. So I need to, just kind of all that thinking, reasoning, coordinating, to actually make all this stuff come together.
No, agreed.
So, and the last thing that we wanted to talk about is this is not agent mode that OpenAI has come out with, which is, I think, a lot of the same agent stuff, but then putting it into its own environment where it can actually interact with, it does things like the agent stuff, but also does operator stuff where it can interact with other systems and do a lot more stuff. So agent mode is different and kind of like on steroids, the next kind of where some people think things are going, but it's not necessarily the same thing as agent AI.
I would say that agent mode and some of the other things, that we're seeing, the various coding CLIs, for example, the Claude desktop system, these are all examples of agents. I don't think they're not, what's the way to put it? They're not the developer side of agents. They are agents that somebody else has built and that you don't necessarily have an opportunity to build yourself. And I think maybe we'll start touching on as well why it makes sense to build your own agent versus try to leverage a super agent, an all-in-one agent. Why, we'll head down that way, and I think we'll head down that way. If not now, in some soon episode, I'm sure.
Yeah. So you want to jump into a specific use case and kind of talk about what might go into solving this particular problem or this
Sure.
business use case? All right. So one of the things I did while I was working at the VA was working on a chatbot that allowed veterans to be able to ask questions about their prescriptions. So The veteran had to log in, and go ahead.
And we've talked about this a little bit in the past. We talked, but back then it was very specifically a voice agent. It was working, and again, there's that word again, agent. It was working around some fixed input parameters and some specific intents, and had a very, very structured flow.
Right. So it was using standard NLU, deterministic routing, coded conversation flows, all kinds, all that stuff. Integrations with API to call to get the veterans' prescriptions, another API to refill their prescription. So that's the problem that we had, or that we're trying to solve, is that the user wants to be able to interact with the agent and be able to ask it questions or search prescriptions. You could find all those prescriptions that need to be refilled, or you can find those that are active that need to be tracked, or you might want to find a prescription by a specific, like the prescription number. So in the case of finding something by prescription number, the output is a single prescription or no prescriptions if there's nothing that matches. But some of these other examples, you might have a longer list of prescriptions. It might be 100, it might be 1,000 if you're going against a whole history of things. And so you have to try to kind of break down this problem of what types of things are we going to need, and why would we need some of these things to work in the agent mode. And one of the things that jump out almost immediately is if you try to include the output of the whole list of prescriptions, the whole JSON array of all your prescriptions with all the details about a given prescription, then that doesn't fit within the context window that you've got. You basically blow that out. And so,
and in some ways, this kind of dovetails with when we were talking about it in the voice context. You don't want it reading out 100 prescriptions or 20 books, or lists were one of the things that we always talked about as being really, really difficult. And we discussed ways that you needed to manage that context. So now we're revisiting this question.
Yep, it didn't go away. It's a human computer interaction challenge that's existed and continues to exist. So so the approach that we're taking is that we're going to, if there is a list of multiple prescriptions that match something, let's say it could be 2 or it could be 20 or more, is then to output or let the user know that there are X number of prescriptions, 10 prescriptions that match this particular search that you did. And then it presents the first one. It allows you to ask additional questions about that first one, and then you can say next to go on to the next prescription. Hopefully with different filter criteria, you can get the list as small as possible, but then you're going to deal with each prescription one at a time. So that's the scenario that we're dealing with. So like I said, one of the first problems is how do you handle such a big list? So both of these frameworks give you the ability to keep track of out-of-band data, I call it, data that's not in the main flow, or is not, the LLMs, you're not going to pass this information back to the LLM and have the LLM keep track of this whole list of things. You're going to store that someplace in state, short-term memory, once again, talking about context engineering. Mm-hmm. So we need some tool that gives us a list of all of our prescriptions, because there is an API call that does that and gives us back this list. And let's say for this example that there isn't any filtering or anything built into the API. It gives you the full 100, the full 1,000, whatever it is. It's going to make one API call and give you that big list. So you need to have a tool that is a get medications tool that its job is to make the API call with all the information that it needs and returns back a list. but it's not, the only thing that's going to return back to the history is found 123 prescriptions.
So, and when you say history in this case, it's what it's going to tell
The chat, yeah.
the LLM.
Yes.
And I think we've talked about this a couple of times. The way the tools work is, a human will say something, the LLM will say, "Oh, I can answer that question using this tool. Agent, go run this tool and get the results and give them back to me." Me being the LLM. But in this particular case, what we really want is a tool that gives something back to the LLM, but has a side effect of loading the full list and maybe storing that in some way. So we have easy access. Associating the full list with the session.
Yes, exactly. So in this case, we're going to do a very simple query, something like list prescriptions. So it's going to say, all right, I'm just going to list all of your prescriptions, how many that is. And so the first thing it's going to do is, because of the description that you give to the tool and the fact that there's no input arguments that's required for this particular tool, it says, hey, it seems like the first thing I should do is make a call to get a list of all the prescriptions. And so it does. And when that list comes back, you're going to stash some of that in short-term state, inside the session data that's outside of what the LLM knows in its history, and you're going to output to the history, I found 123 medications. So that's kind of the first tool. But already the agent has had to take what the user said, what the system prompt was, which you gave some additional information about, that this tool is to find prescriptions and other things, whatever it is in the system prompt. And so it's figured out with its reasoning that it needs to call a tool. It figures out which tool to call, gets the list of medications, and now we have that list of medications. If you look at the Agent SDK, the OpenAI Agent SDK, they call that specifically context. So there's a way that you can set up before you make the call to say these are the things that are going to be put into context. And so we're going to have two things in context. We're going to have the meds list, which is the list of all medications, and we're going to have the filtered meds, which is just a list of the prescription numbers for all of those, because that's going to be a lot smaller than storing the whole list of prescriptions. So if you look at the Microsoft Semantic kernel, there's a little bit more involved in setting that up. It's pretty straightforward with OpenAI, but with the kernel, you set up a kernel, which is you use a builder, and you can use dependency injection and to figure out if you need a logger and how to configure this kernel, and you configure this kernel with a list of functions which are equivalent to tools. After all that happens, then you can pass to each of the functions this kernel object, and there's a data object off of that kernel where you can just store things.
That's interesting. On the LangChain side, it calls the session-based information the state. And the way it manages, literally the essential part of LangGraph is about managing that state more than anything else. And that state includes your conversation history with the LLM, but it can also include anything else that you want.
Okay, interesting.
There's also this notion of an outside the session state, and that is managed in a completely different way. And while tools have access to both of those, that's not the default behavior of a tool, but it can. It also has these other nodes in the graph called action nodes, which do have access to both the state and the larger state. AGK kind of bundles all of these into a single thing. So while you have state, there's session state and global state and user state and different kinds of state, all of which you manage using the state manager.
Okay. So yeah, both of these frameworks are fairly the same. The Agents SDK, I'll just shorten OpenAI Agents SDK to just Agents SDK and Semantic Kernel. they both have ways of passing that context or that kernel object, which has state on it, into the tool itself. So basically, it figures out to call the tool. The tool has access to that state. It can set the response of that API call to get the list of prescriptions into that state or context, and then some shorter response back from that tool, and it goes back to the LLM, who then figures out, do I have enough information to answer the question, or do I have to find another tool to help me? So, any questions on that part so far?
Nope. And again, what we've talked about in the past is that loop is, what we call a react loop, reasoning and action loop. Do I have enough information? If I do, I'm done. If I don't, do something, check again, do I have all the information?
Yep.
And keep doing that.
Yep. So the next tool that we have is a tool that's going to help interpret what the user said into a search criteria. The name of that tool, let's call it Get Filtered Medications. And it's going to have as its input some object that has a number of different things. So like you might say, find aspirin. So drug name would be one of those things that if it had a value, then it could be used to help filter that big complete list down to those things that match, and how you match in that case, by drug name, is it contains, is it fuzzy match, is it an exact match? That's stuff that you can decide on how you want your tool to work. So in this particular case, I've got drug name, I have prescription number. So if they say find prescription 1, 2, 3, 4, then each of the fields in this search criteria object is decorated with, or annotated, however you want to call it, has descriptions that talk about what each of these fields are used for. And that helps the LLM figure out, well, how am I going to interpret what the user said into, and so it's kind of, giving that structure on the input helps it kind of refine or think about how to take that natural language and turn that from unstructured into structured.
Right. And again, this is something we've talked about in general terms for a good 2 years now. When I was saying that the LLMs were really great at turning from human language to computer language and having the computer understand what it was that we were doing, bridging that fuzzy human digital computer divide, that's the sort of thing we were talking about 2 years ago.
So,
Sorry,
and there's that's good. So the other filters, just really quick, there is this concept of, is this prescription an active prescription, or is it something that's it's expired, or the refills? So something, another term we'll call it historic. So something that's different than active, or is the prescription, or is in this case, is the prescription a specific prescription that in this case is being filled by the VA in this example? Or is it some additional medications that's in some other system that you still want to keep track of in your list? So so VA not versus non-VA. So that was another filter. Is the prescription refillable? Every prescription has a status. A certain number of statuses determine if it's active. Some of those statuses also indicate if it's,
Now let me ask you something.
If it's in a refill state. Go ahead.
Does each one of these attributes turn into a different function or a different tool that we define? Or do we have a broader filter tool and it can take parameters of, what needs to be filtered and what the filter criteria is?
In this system that we're talking about, the way that I approached it, we had 3 tools. We already talked about first tool. We're talking about the second tool, which is Get Filtered Medications. So it's got this filter criteria as the input.
Okay.
The output of that is going to be an array of prescription numbers that is going to go into our context or into our data or in our state, right, or into our short-term memory. But, and there's different approaches that you could try, but in this case, I just output the list itself of prescription numbers back to the LLM. So now the LLM knows the whole list of just the list of prescription numbers. And in the instruction prompt, it's talking about that you go through, that you're going to display one prescription at a time, and then you're going to be able to go next to the next prescription. And it kind of already figures out from that output that, like, oh, the first one is the first one in the list, and when I say next, I need to go and look up the next one in that list. So that's the second tool. So it does use context, but it also does output stuff so that the LLM knows what that list of prescription numbers are.
That's really interesting. That's a very interesting approach.
Yeah, I was kind of surprised. I wanted to see if it was going to work out of the box, and it seemed to work pretty, pretty well just like that. And that's kind of also, as a developer, I'm like, I've got this probabilistic system that's keeping track of a list of prescriptions and iterating through, and there's still something in my mind as a developer that says, like, I should be keeping that into I should have a current index.
I should have a counter and an index and and a function that's next and a function that's previous and
Yeah, and so I haven't really tested that out, but I think for me as a developer, I would probably feel better if that type of next iteration and figuring out what the current prescription was, or the next prescription that you were based on where you are in the list. Have the LLM figure that out? I'd probably rather figure that out myself. So that's the next tool, and that's kind of its job, is to get back this filtered list. And there's little hints inside the prompt that says this is what you really want. When you say next, you're really nexting through the list of prescription numbers. And the last thing is a tool that is display a single medication, and its input is a prescription number. So now with it being decorated or described as, as the thing that is used to display a prescription, and the fact that you require an input that is the prescription number, and you've got a description on that input saying that, what it is, all that stuff helps behind the scenes. So when you say list prescription, the reasoning is, oh, I need to go get a list of medications. Oh, I need to filter this list of medications to a list of prescription numbers, and because I need that prescription number in order to display the current prescription. And that's basically what it does. I didn't talk about the logic, but basically on the filter part, all those inputs turn into just filters that you apply to the master list until it just gets smaller and smaller to only return those things. So all that logic is just inside the tool to get that list to the smallest list possible based on the input. And then this next tool takes in one prescription number, goes and gets that list that we have out of band of all the prescriptions, looks up the one that has that prescription number, and it outputs the whole object, JSON object, as the output of that tool, which gives you the ability then, because it's got field names and it has the different field values, you could ask different questions. Maybe it only shows prescription number, prescription name, refills remaining, and a couple of things. And maybe your search was find trackable. And so that the prescription's trackable, or you could even ask, is this trackable? And it would say yes or no. It would look into that object. That's the most recent thing in the history. And it would find, oh, it is trackable. Yes. What is the tracking number? So you can ask all kinds of questions without having to code all those questions, which is definitely what I had to do before.
Right. And that's like one of the beauties of using these kinds of agentic systems is that it's the LLM that is turning that request and making sure it has the information that it needs to fulfill that request.
Yep. So, and then when you, and it also, because of the prompts, it's going to give you like a little hint at the end. It says you can go on to your, move to the next prescription. And so if you do next, then you pass that back to the LLM. The LLM's like, well, I already have a list of my medication, and I have my list of prescriptions that's filtered just to the prescription numbers. So I'm going to find the next one in the list. And so it doesn't have to make the filter call again because that's already in the history. So the only tool that it needs to call is display with the next prescription number in the list, and then that displays it. Now you have a history.
Hang on.
Yeah.
You know, all I need to do is call display for the next one in the list, and it displays. Behind the scenes, that's not what the agent is doing, though. What the agent is doing is it's saying, give me this item, which happens to be the next one in the list, but nothing's managing that except the LLM conversation history. Yep. What it gets back is a structured output of that item. And then the LLM, guided by your prompt, chooses how to return that in a human fashion, right?
Yep.
Now, one of the kind of, I would almost say, neat things about that, and we've had a couple of people talking about this so far. You know, we've had Noble on, we've had Lee Malin on talking about the dynamic user interface. So you can almost see how this fits in on that dynamic user interface that, you know, it's now going to show you, maybe, you know, instead of saying display this as text, you might say format this result as HTML. And you'll then print that HTML in a fancy format with buttons that might drill into something, or who knows, you know, but that's kind of what the tool is doing is it's pulling out the information and then giving it over to the LLM, controlled by your prompt, to format it and display it. And that's kind of powerful and amazing.
Yeah, and like I said, it's kind of blew my mind once I walked through it and thought about it differently, because instead of 20 different intents with all the different utterances and figuring out what the different handlers were for those different things, and like if I'm in the position where I'm asking for the list, that's different than if I'm in the state of where I'm going one by one through the list, because I'm keeping track of this counter, and so that's a different part, you know. And yes, no in that context is different than would you like to refill your prescription? Yes, no. So it's all that stuff that you're having to keep track of, and with some good prompting and the appropriate tools and tool definitions, then you get a pretty powerful system that has some guardrails all around it.
I think what's also interesting is that it lets a person ask questions like, you know, when was this prescription last filled?
Yep.
Was it filled on the same day as the other prescription? You know, as the previous prescription. And we as developers don't need to do anything special about that. The LLM will determine, well, I know the previous prescription, I know the current one, I can give you that answer. Or if it doesn't have the information, it can go and, you know, ask a tool about it and then determine the answer. It's that kind of power that these systems build that we didn't have with our intent-based systems.
Yeah, and I'm glad that you brought up structured output, because that is also part of the, you know, context engineering, you know, tool set, is that, or, you know, not belt, whatever. I say tool set, but I was like, I don't want to get that confused with tools, because tools, structured output are two different things. But the you know, core concepts of context engineering is also structured output, so that you can give it in a specific format and be used. And you don't necessarily have to have the LLM generate the output either. You could set up a system where the output or the end of that tool chain is a success, and you can then look at your state and say, this is the current prescription that I'm on. And you could, like in our case, we were doing a chatbot, so we would have a text-based output, which would be which would be something they could read, or something that the voice assistant could speak out. But then we also provided an adaptive card, which was part of Microsoft's adaptive card framework, where you could define kind of more of a structure of some information, and it would provide it in a you know, a better, cleaner format for a visual. And so you can still do that. You do not have to necessarily have the LLM generate what the output is. You could provide structured output as well to the output of the whole system and have your app work with that structured output as opposed to text.
One of the things I find neatest about that concept, and I know LangChain.js makes this very, very integral into it, and I'm pretty sure almost all the others are going to do the same thing, is that means that, okay, you've now built an agent, it returns some structured output. That agent can now become a tool for another agent.
Yep.
So this other agent now just knows that, look, here's the parameters that this sub-agent requires. I'll tell my LLM about that, and in conversation, if, that now comes up as part of the conversation, here's the interface to go ask this other agent these questions. That notion of having sub-agents that handle smaller tasks iteratively, and, you can kind of pick up where you left off and then return back to the final answer, that I think is going to be one of the beauties as we see these things evolve, is that, instead of a tool call doing one thing, it's going to be doing a whole bunch of things behind the scenes that are now abstracted behind this one tool call.
Yep, exactly. So I didn't really get into a lot of detail on how to, specifically use Agent SDK or Semantic Kernel, but both of them handled in their own way those exact same concepts that we talked about. Being able to set up defined tools, set up a system where you could specify a system prompt where you can take what the user typed into the system. In this case, I just had a console input that would then call the bot and get the output and spit that back out to the console, standard in, standard out stuff. And that both of them worked that same way. So there was basically 3 different sections. There was the stuff that you have to do to get the agent created in Agents SDK, or the kernel set up in Semantic Kernel. So there's the setup phase, there's the definition of the tools, and then there's the actual part where you're going to make the call. And so that is, prepping a chat history, setting in the user prompt for what the user entered in, making the call to the LLM, and then and getting the response back. They all do things just slightly differently, but in the end, they provide all these abilities in just different ways and in a different programming language.
Yeah, the programming language is the easy detail.
Yeah, it actually is.
And that's kind of the interesting thing, is that they're all, at least on some level, doing the same sort of thing. I mean, what I found interesting when I started diving into it was just how much ADK and LangGraph on the surface worked very, very similar to each other. But as I started diving into the details were very, very different. And it sounds like some of that is the same, that, on the surface, They work pretty much similar, but the devil is in the details.
Yeah.
So I'll tell you what, I think this is a good place to stop. Maybe we'll pick up some more of these devilish details next time. As always, you can find us both on LinkedIn. You can leave comments below. Hope you like, subscribe, and share, and we will see you another time on Two Voice Devs.
Two Voice Devs. Thanks, Alan.
Thank you, Mark. Take care.
All right, you too.